Okay, so again, we're doing chapter 7-6 double angle formulas, and that's our goals, is to use these formulas. If you're somebody at home, I hope you have your packet or this notes out. If you don't, you better write these formulas down so you have them for the test. So as I take a look, double angle formulas, okay, I've got the sine of 2 theta. That's equal to 2 times the sine of theta times the cosine of theta. So the idea of this formula is, if I know, like, say, let's just use an easy number. Like if I want to know if I have the sine of 30 degrees and the cosine of 30, I can plug that in and find the sine of 2 times 30, or 60 degrees. This is a formula that allows me to find the double angle. So I'm just multiplying by 2 of that angle. So again, if I have like the sine and cosine of 45, I can plug those in here to find the sine of 2 times 45, or 90 degrees. So that is, this formula allows me to use it. Okay. So sine of double theta is 2 times the sine of theta cosine of theta. And when you look at cosine, you have 3 options. So if I have cosine of double theta, that's equal to cosine squared minus sine squared, or 1 minus 2 sine squared, or 2 cosine squared minus 1. So for cosine, you have 3 options. Any one of those 3 will get you the correct answer for cosine of 2 theta, or double theta. Okay? Now, if I had to choose, I would choose the first one. The first one is the easiest, in my opinion, because you don't have to deal with the issues that you deal with these two. When you're working with these two and you start plugging things in, when you start plugging things into these two, then we start running into, please excuse my dear Aunt Sally, issues, and you guys start messing those things up a little bit. Sometimes you multiply by -2 or 2 and then square it when you're supposed to square things first and then multiply. So we got to make sure we're taking care of the exponents. Okay. All right, so we got basically 2 examples. On each example, we're going to do cosine of double theta and sine of double theta. Okay. So let's get started so you can see what you're going to be doing here. All right. So we're going to use those formulas. Again, I hope you have those written down. If you don't have this note sheet, remember you can use notes on all tests and quizzes. So here we go. So I've got sine of double theta, and they give me cosine of theta is 12/13. And theta, the way I read this is theta is between 0 and pi over 2. Okay, so as I take a look, I'm going to do part A. I've got the sine of 2 theta. As I look up here in my highlighted yellow one, that's 2 sine of theta and then cosine of theta. Right? So I'm going to get the sine of theta here and then cosine of theta there. Well, cosine they gave me 12/13. And what they didn't tell me is what sine is. So that's where I go off to the side and I have to figure out, well, what in the world is that opposite over hypotenuse leg? Okay, they gave me A and H. We want to go ahead and find O over H, the sine, the SO from SOHCAHTOA. So off to the side, I'm going to go ahead and make that little triangle. This guy tells me what quadrant I'm in. Again, this is from 0 to pi over 2, or 90 degrees. So what quadrant does that tell me to put it in? This is in Q1, because 0 is there and 90 is right there, right? So as I draw this guy in quadrant number 1, all right, this is O, this is H, and this is A. They gave me cosine, which is Ka, A over H. They gave me A is 12 and H is 13. Well, then I got to find that missing side. I got to find what opposite is, right? So as I take a look, you can do a little Pythagoras here to find that, right? Or know your Pythagorean triples. This is a triple. Does anybody know what that number is? This is a blank 1213 Pythagorean triple. Do you remember what this one is? It's 5, yeah. So again, you can use Pythagorean theorem if you need to. You can use that a squared plus b squared equals c squared. A squared plus 12 squared equals 13 squared. 13 squared is 169. 12 squared is 144. If I subtract 169 and 144, I get 25, and the square of 25 is 5. Okay? So I want sine. I want O over H. So in this case, we know O is what, 5? And H is 13. Okay, and then we just simplify, guys. So we go off to the side, simplify this. When you're multiplying by 2, just again, that's to the top. So that's pretty easy, right? 2 times 5 is what, 10? And 10 times 12? 120. And on the bottom, we get 1 times 13 times 13. So 13 times 13 is 169. So final answer, the sine of double theta is 120 over 169. Not too bad, right? If you know cosine, you just got to find sine. Once we have sine, then we can go ahead and answer the question pretty easily. As I take a look at the next one, they want me to find part B, which is cosine of double theta. And this is where you have 3 choices on what formula you want to use, and it really doesn't matter. Like, for instance, if they give me cosine and I only, I don't want to find sine, then I could use this one right here. But I know sine and cosine here, so I might as well just use the top one, okay? Because that's the easiest one to use, okay? So I'm going to go ahead and plug that in here. So part B, I've got the cosine of 2 theta. That's cosine squared of theta minus sine squared is what it says. And they gave me cosine, that was 12/13. And then we found sine over here was 5/13. And then we simplify. When you square a fraction, you square the top and square the bottom, or use your calculator. 12 squared is 144, and 13 squared is 169. Minus, notice the minus is on the outside, so it stays minus. 5 squared is 25, and 13 squared again is 169. Again, the nice thing about when you're working with this one is you're going to have common denominators because you're taking the h and squaring them both. So now I just got to do the top. What's 144 minus 25? 119 over 169. If you can reduce, you should, but I'm pretty sure that thing doesn't reduce. And that's it. That's the cosine of 2 theta. Okay. So big idea here again, guys. Theta is in quadrant number 1, right? Let's say that theta is like 20 degrees or something like that. Okay. Well, if I double that, 20 times 2 is 40. That's going to put me back into quadrant number 1, right? So 2 times 20 is 40 degrees. 40 degrees is in this quadrant. So if I made this triangle, my adjacent leg for this angle would be 119. The hypotenuse would be 169. And then opposite would be 120. Okay? I wouldn't be able to figure that out without this formula, because this allows me to take information I know to find sine and cosine of an angle that's double that. Okay? Now I have no idea what that angle is. I could find it, but I don't really care. So let's move on. Any questions, y'all? That's not so bad. Usually this is like one of the easiest sections for people. So let's take a look. Let's do it one more time. It says again, use the given information about theta to find the exact value. Again, they want sine and cosine of double theta. The information that they're giving us is cosecant is 2 over 1, and then cosine of theta is less than 0. Okay? So first things first, if I know cosecant is 2 over 1, then I should know his buddy. What's his buddy? Who's his buddy? Sine, right? Cosecant is 1 over sine, so this guy is sine, which is 1 over 2. Remember, this is h over o, Santa's favorite trig function, h over o, hypotenuse over opposite, ho. So this is so, which is o over h, which is 1/2. Okay? Now, I always want to make sure I draw this in the right quadrant. So this is why I always draw the x and y axes, because I want to make sure, guys, that I'm getting my sine and cosine signs correct. If I took a look at that last quiz, some of you guys got your pluses and minus mixed up because some of you guys are just drawing triangles without using quadrants, or you're forgetting about your negatives and positives. Okay, so we got to watch out for this. So as I take a look, sine is positive, so I go back to this idea: all students take calculus. I want to know where to draw this triangle, okay? So sine is positive in 2 quadrants, above or below. AS or TC, where is sine positive? A and S, they're all positive, that's A, and sine's the only one positive. Then I take a look at what other information they gave me. They gave me cosine is less than 0, that means negative. Okay, so again, where is that adjacent leg negative, on the left or on the right? On the left. Okay, so cosine is positive on the right, A and C, cosine, and all are positive, and 1. So that means it's negative in that other quadrant, quadrant 2 and 3. Well, the overlap happens right here in quadrant 3. Or excuse me, quadrant 2, not quadrant 3. All right, so I'm in quadrant 2. Again, working from this reference angle. This is O, this is H, this is A. And they gave me sine. They gave me sine was 1/2. So I have 1 and 2. Now I can use Pythagoras to find that missing side, or I know this ratio of sides. I've seen this reference triangle before. What is this guy? This is a 30, 60, 90, so we know what this guy is. What's this one? A root 3. Now don't forget this is in quadrant 2. So when I go to the left, that should be a negative, and when I go up 1, that's positive. Remember, you're always kind of plotting a point at the tip of that terminal side. So that's left and up. So negative is left, and then positive is up. Okay? So far, so good. I hope we're taking notes on this stuff. Oh my gosh, you can't learn this stuff through osmosis, right? Oh man. All right, so as I take a look, now I have all the information I need to find part A. I want the sine of 2 theta. That is 2 sine of theta, cosine of theta. We know sine of theta, that was given to us. And now we want cosine, which is A over H, right? Again, I'm showing lots of work here, so you can kind of follow what I'm doing. So, what's A and H of this triangle, y'all? A, what's A? What's the adjacent leg? Negative root 3, awesome. And the hypotenuse is 2. And then from there, it's just simplifying, right? We got everything plugged in, now it's just chug. So think of this as 2 over 1, all right? So in this case, the 2's are going to cancel, right? 2 times a half just cancels out, it turns into 1. And that leaves me with negative root 3 over 2. So final answer for part A, sine of double theta, negative root 3 over 2. Easy peasy. So the last thing is, if we want to find cosine, you have 3 options, right? So if I want to do cosine, we have 3 options. Which one do you want to use? Do you want to do the cosine squared minus sine squared, or one of the other 2? Easiest one?
Yeah.
Or a harder one?
Easy.
Easy? So you trust me the other 2 are harder?
Yeah.
Yeah? Okay. Well, it's good that you guys trust me. I would never lead you astray. All right, so again, cosine of double theta is cosine squared minus sine squared. Again, I think this is super easy to use. So we're going to take that ratio of cosine, which we had up there was a negative root 3 over 2, and we're going to square it. And then we're going to subtract sine squared, which is 1/2, and then quantity squared. And then we simplify. When I square a fraction, I square the top. So I'm going to take negative root 3 and square it. So negative root 3 times negative root 3. First off, negative times a negative, or a negative squared, is positive. And then what's root 3 squared? 3. And then 2 squared. Don't forget to square the 2. 2 squared is 4. How easy is that? And then I do the next one. Now notice the minus is on the outside, so it still stays minus in between. I have 1/2. I square the 1, that's 1, and I square the 2, that's 4. So I take 3/4 and I subtract the 4th. That's 2/4, which we know is 1/2. So I got my final answer for part A and part B. I got sine of double theta was negative root 3 over 2. And then I got cosine of double theta is 1/2. Okay, now let me zoom out so you guys get the big picture, because some of you guys still don't understand what the heck are we doing. All right, look at the triangle that we just drew here up here. Okay, if this is 1 and this is 2 and that's negative root 3, we should know this angle. What's this angle right there? That's 30. Well, theta is not 30. Theta is from your initial side to your terminal side, right? That's theta. Well, how big is theta if that's 30 and the whole thing's 180 there? 150. Okay? Well, what we just did is we came up with double theta, right? So what we just did was 2 times theta. We did 2 times 150, which we agree is 300. Well, 300 degrees is in quadrant 4. That's 300 right there. So if I make this a little reference angle, that's 60, right? Because 360 is 360. And now I have my little reference triangle. Across from 60 is root 3. Because it's going down, it's negative. That's 30, so that means that's 1, and this is 2. So when I look at sine and cosine of this 300-degree angle, sine is negative root 3 over 2, which we came up with right here using our formula. And then cosine was 1 over 2, which we came up with right here. Okay? So again, if I know sine and cosine of a certain angle, then I know sine and cosine of that angle double. Okay? So I knew sine and cosine of 150, which means I can use my formulas to come up with sine and cosine of that angle 300. Okay? Because it's double that, using my formulas. Okay? That's a big idea, using our formulas so we can come up with those exact values, which is a nice thing to do, especially if you can come up with theta, sine of theta, cosine of theta. And guys, that's it. Chapter 7-6 is done. That is the last trig chapter that we have to talk about, and then we start diving into calculus stuff after next week.